We see now a mechanical system in there that I deliberately have not put the elements, although you the element names, but you recognize it right there what they are. And the reason is because I want to try something new, and that is to draw my bond graph model right on top of the physical system, which will make me identify exactly what the elements I have, but also not only that, create a one-to-one correspondence from the bond graph model to the physical system. So in this particular case, maybe I'll just use a different color so that to illustrate this, what I need to remind you is that on the right hand side here I have made a list of 5 steps that you should do to build the bond graph model that would lead you to a nice graph done over here. We could put the labels, but like I said, I am trying to use this as a background. Use a one junction to represent the distinct velocities. Alright, let's do that. So in this case, I'm just going to use the one junction here for the velocity here, which would be, let's call it x1 dot, like that. And I'm going to put the one junction for the other velocity, which is x2 dot, like that. And then I'll put another velocity here for the velocity of the ground. How is that? Yeah? Done with step number 2. Attach the elements that experience those velocities. Good. I'm just going to put in here an I element with value, in this case I put it M1, which is this up here. I'm also going to put a source of effort over here with value M1G. I'm going to put this in here, another I element with value M sub 2. And I am going to put here a source of effort with value M sub 2G. Right, let's leave this one in here. Okay. And the ground is a source of flow here. Source of flow, like that. This one's already because they are all defined with power flow and causal marks, I'll just put them in there for the sources. So that's step number 1 that 3 that I have done that. Then it says use zero junctions to represent the velocity differences. So the difference between the ground and this is going to be represented by a zero junction, which I'll put it over here, and I say okay, x2 dot, like that. The other velocity difference that I have is this one over here, which is the velocity x sub 2 dot minus x sub 1 dot, like that. Alright, so that's my step number 4. And step number 5, it says attach the elements that experience those velocity differences. In this case, the C element in here, the C here, with value, I would say 1 over k sub 2 here. I'm calling this 2. And in here you have the C element and an R element in here that experience this difference. See, because these two elements are seeing the difference between the two masses. So in here this would be a C element with value 1 over k sub 1. And this would be the, and I have also done it on top of the system. There's a one-to-one correspondence of the physical elements to the system as well as to the kinematics, completely consistent with the motion of the parts, the components of the system. Now, one thing that I can see in here is that you could simplify this ones right here. But given the circumstance in here that I want to make the process as simple as possible, we will leave those in there. One thing that we should do though is to assign the causal marks, because remember the title, it says system equations, and causal marks are responsible for those equations on the way the equations are written. So I need to have them in here. So if this is a flow to the 1, then this makes this one like this. And then we put the seeing integral form. See, guess what happens? It sets these other ones like that, the other two, because the zero junction needs only one F or N. So this, you have this 2 like that, and now we put this in integral form. And that flow makes this one like this and completes that. We can assign the integral form here. Doesn't matter if we go to the C over here, but maybe we should, to illustrate that if you put the integral form on there, not much happens. And so we need to try the I in there. That sets the flow here, and that makes this like this. Now if you have this 2 like that, then this has to be like this. And in doing that, sets the thing. I need to put some numbers in here. Yeah. And I'm gonna, although the sequence makes no difference whatsoever, and then I'm gonna call this 3, and then this 4, and this 5, and then this 6, and then this 7. Help me if I miss one, okay? 9, 10, 11, 12, 13, and 14. 14 bonds we have. Okay? One thing I want to make sure is that everybody is clear with this, that everybody is clear with the model the way it is, or if you have any questions about what is what with the model in here. Because now, once we have this, we are ready to write the constitutive equations of the system. The way I like doing this is I'll just do like E1 is started with E1 and then go to E2 like this. E1 is equal to E sub 2 based on this causal mark, and F1 is equal to SF1. And then we go E sub 2 is equal to what? E2 here is equal to E sub 3. And what's F sub 2 is equal to F sub 1. And then what is E sub 3? E sub 3 is equal to E sub 4. Right? To E sub 4. 2 minus F sub 5. And then you have E sub 4 is equal to 1 over C sub 4 Q sub 4, and F sub 4 is equal to F sub 3, and then you have the dq sub 4 dt is equal to f sub 3, f sub 4, excuse me. Okay, this is the first differential equation coming from the C element. E sub 5 is equal to E sub 3, and f sub 5, this f5 is equal to f sub 6 minus f sub 8 minus f sub 7. So what coming equals to what gets out? F sub 5 is equal to f6. No, f sub 5 plus f6 is equal to f sub 8 plus f sub... What am I doing? Go back, excuse me. f5 here is f7, that's what it is. I was getting a little confused. And then we need to do it for E sub 5. No, E sub 6. Well, let's just keep it there in there, because I really want the graph. I want to grab the graph here in the picture. So where are we? In E6, right? 5. Yeah, so let's go to E6. So that's where they are. So E sub 6. See, I am writing individual equations. Is AC6. F sub 6 is to F sub 7. E5 plus E6 E7 is E5 plus E6 minus E8. Okay, this is F7 is equal to what? 1 over I sub 7 P sub 7, and that dP sub 7 dt is equal to E sub 7. And then you have E sub 8. Yeah, I don't want to raise too much. E sub 8. Where is the 8? E sub 8 is E9. And what is F sub 8? Is F7. Because CF8, this is the one that caused the flow on there. E9 plus E11 what's F9? F9 is F8 minus F12. What is E10? It's 1 over C times Q sub 10. So we are up to the number 10. What's F sub 10? Is F9. And what is E11? Is equal to R11 times F11. E11, so that's the is this. So F11 is equal to what? To F9. What is E12? E12 is equal to what? The 12 is here. Is E9. E12 is E9. And then what is F12? F12 is F14 is equal SE13. So we have so F13 is equal to what? F14, and then we have the F14 F D. No, let's go E14 is equal to E12 plus E13. But F14 is equal to 1 over P4, and then we have that dP14 dt is equal to E14. So we have these differential equations that we need to do in the Cauchy form. We have, am I missing any one of them? This is one, and this is number 2, and we have one over here, and we might be missing one of them. So we have dq sub 4, right? We have that one. We have the so and the twice. So we have finished the equations. There's only dq10 dt is what I think we're missing in here. Right here, I would put it in here. dq10 dt is equal to f sub 10. That's the fourth equation that we have. Right? Now, these are the constitutive equations. In themselves, the entire system of equations, they are unique and they are assembled all together to act together and to become a set of differential equations where the ones that are encircled are the derivatives calculated. So now what I think I need to do is to go ahead and make substitutions in here and just build the Cauchy form of these equations. It's not where did it insert it? Huh? Okay. Where here? Yeah, here. No. Disassembling something here. Yeah, here we go. Yeah, I just want to make sure that we make it perhaps a little bigger also. Yeah, there we go. I hope I didn't mess things up in here too much. Yeah, there we go. So I'm going to use these equations that are circled to produce the Cauchy form. In reality, in here we're going to go first, and I would say, okay, if dq sub 4 dt is equal to f sub 4, then it follows using 5, and f sub 2 is f1, and then f5 is f7, and what is f1 is sf1, and then minus f7 here. One over p sub 7, like that. So that's one of the equations right there that we have just finished. In fact, maybe what we should do is change the color and rewrite it here so it would be in the center and elegant. dq sub 4 dt equals to sf1 equation, in dp sub 2 dt is equal to, no, it's not dp2, dp7, excuse me, is equal to e sub 7, but e sub 7 you could see is e5 plus e sub 6 minus e sub 8. Okay, so in here we have to continue the substitutions. What is e sub 5? In this case is e sub 3 plus e sub 6, which is up here someplace, is se6. Minus e8 is e9. And here e sub 3 is e sub 4. I need to already begin putting in terms of the state variables. What's the e sub 3 is what we need to do here. E sub 3 is e sub 4. And what is e sub 9? Is q e10 minus okay, so let's just erase this. This thing here is e sub 4, which, you know, and then plus se6, and then minus e sub 9, which is e sub 10 minus e11, like this, to use the sign, the minus sign, and substitute. So e sub 4 in this case is se6 minus e10, which was 1 over c10 q sub 10, and then minus e11, which is going to be r11 times f11. I think we have everything already done. The only thing we don't have is f11, so let's do that separately so we can substitute and not have to rewrite the equations every time. f11 is f9, but f9 is f8 minus f12. Okay, and what is f sub 8 is f7, and what's f sub 12 is f14, we have F7 is 1 over I7 times P sub 7, which is what? F14 is 1 over I sub 14 P14. 1 over this I sub 14 P14. Okay, we have this, that is our F11 in here. So why don't we just put this in here? This is, let me, so all we got to do now is to put this F11 with this. So this would be 1 over C sub 4 Q sub 4 plus AC6 minus 1 over C sub 10 Q sub 10 minus R11 multiplied by 1 over I sub 7 P sub 7 minus 1 over I sub 4 P14. And this would be the second equation, dP sub 4 dt. Hopefully is the one that I'll just circle in here with the red, and so that you can see this is number 2. And we only have the other 2 equations in here, and that is, in here you have this dq d10 dt is equal to what? dq10 dt is equal to F10. And what is F10 equal to? See, F10 is equal to F9, and F9 is F8 minus F12. F10 is equal to F sub 9, but we already have something like that up here someplace. Right here, see? F9. So this F9 is going to be equal to this. So I'm just going to use it from P sub 7 minus 1 over I14 P14. And that is going to be the third equation. Well, let's write it really well here. dt, this is going to be equal to 1 over I sub 7 P sub 7 minus 1 over I14 P14, like that. And that is my third equation. And I will have only one more to go to finish this whole set of equations in the Cauchy form. I'm just substituting. Backward substitution, dP14 dt equal E14 is the last one that we need to deal with. So this is dP14 dt is equal to E14, it says. But E14 is E12 plus E13. This is E sub 12 plus E13. And the question is, what is E12? E12 is E9. Okay, this is E sub 9. E13 is what? Is E13. So it's going to depend a lot on E9, which is E10 plus E11. And what is E sub 10 in this case? 1 over C sub 10 Q sub 10. Plus E11, and then plus, let's not forget the C13. What was the other one? Was E11. E11 is R11 times F11. R11 times F11, and then plus SF is E13 place up here. Although we could use it. Yes, no? Right here, see? And so F11 is this. So why don't we just do that? We'll replace it and then we are done with this. dp14 dt is equal to 1 over C sub 10 Q sub 10 plus R11 multiplied by this, see? Which is 1 over I sub 7 P sub 7 minus 1 over I11, I14 P14 like this, plus SE13, and this is, I have finished the other equation, and I'm just going to put the framing here. So that there you have the 4 equations in the Cauchy form, all 4 of them.